Our project is deep-based approach for music genre classification, and it is guided by Dr. Bhuvneshwari ma'am, CSE department. I am Ganesh.
And I'm Bhagwati Shankar. As we have introduced ourselves, our project is deep-based approach for music genre classification. And the problem statement is that humans are not able to classify the genres manually, and there are many machine learning classifier models uh, in the existing approach, but it is not efficient enough to produce good results. So we have proposed this model, and it gives output with high accuracy. And the objectives are to extract features from audio samples and apply hyperparameter tuning for tuning the parameters with the help of particle sum optimization technique, and the genre will be classified as the output. And we have proposed two models, one of the model is the visual feature model. In the visual feature model, we will segment the audio files in the dataset, and the segmented audio file will be used to generate spectrograms, which is the pictorial representation of the audio file, and it is fed to the neural network for training it. And during testing, an unknown audio file is taken, and it is pre-processed the same way as earlier, and the spectrogram is generated, and it is fed to the neural network for testing, and the genre is classified. And these are the modules. The first module is the data segmentation, which comes under data pre-processing, where 30-second audio files are split into 10 equal 3-second audio files, and CNN is taken because it is superior at image processing. So we have taken CNN for processing spectrogram, and this is the result of the data segmentation, which results in data augmentation. The data gets increases, so it will reflect in the accuracy. And this is the spectrogram for the 10 genres available in the dataset. Uh, the feature map for the spectrogram in JohnerNet has been visualized here, and this is the architecture of the model, and this is the summary of the model, and this is the output of the model, where you can see some of the misclassifications that are present in the table because the spectrogram is not efficient enough. So we have proposed another model, which is the acoustic feature model, where we will extract the features straight away from the audio file and store it in a CSV file, and then feed it into a neural network, and the weights gets optimized by Adam, and the hyperparameters are getting tuned by particle sum optimization. And an unknown for testing, the an unknown file is taken, and features are extracted, and it is given to the neural network for testing, and the genre is being classified. The modules are the same. The data will be segmented, and the feature will be extracted, and the parameters will be tuned with the help of particle sum optimization, and at last classification occurs. This is the result of the data segmentation, and this is the features available in the CSV file, which are stored once we extract the features from the audio. And this is the architecture of a model used in acoustic feature model. This is the summary of the model, and this is the output of the model, where you can see the classifications are perfect. So we have stated that the acoustic feature model outperforms them all, and existing machine learning models are also not efficient enough. So we propose that the acoustic feature model using CNN is perfect for music genre classification, and it outperforms all the existing models currently available. And the optimization has these parameters, and the hyperparameters that are getting tuned in the model are the number of filters, and the size of filters, and the size of pooling layer, and the strides. And this is the output, where you get a diagonal matrix, which represents the accuracy of the model. uh, here we get to compare the acoustic model and the genre net which we have used in the visual feature model. The acoustic model is good enough, and the accuracy is high and loss is less compared to the genre net. And this is the dataset, which is a benchmark dataset we have used in this project, and the hyperlink for the dataset available. The outcomes are that the audio samples are getting extracted. Features from the audio samples are actually getting extracted, and the CNN architecture is optimized, and a software is created to classify the challenging audio samples. The result with significantly greater efficiency and accuracy are produced when compared to baseline architectures. Social impact. This approach can be useful to arrange the songs based on genres, because in the existing solutions we can't arrange the music based on genres. We just arrange based on the arrange it based on the chronological order. So this model will be helpful in that aspect. And our project acts as a music recommendation system, where it can recommend a song based on the previous genre of the song. And when an author publishes a new song, it can be used to determine the genre of the unknown song. So it would be helpful in terms of music information retrieval system. So it helps in three aspects. And the economic aspects is that this can be used by sound engineers and music analysts to classify the songs, and if they get to employ a separate person for this job, it would be expensive. So this could prevent that such situations, and this systems can be a good replacement of existing genre classification and prevents misclassification and unnecessary losses. Thank you. So finally we conclude that the acoustic feature model is far better than the available models in the world, and the accuracy is so good. So we propose this model as a best one to classify the genres, and it is more accurate and precise. So it is a good one to use for this purpose. Thank you.